In this video, we will be looking at linear system applications with a elimination method focus. So let's start with our first example. Wendy rented a car for 6 days and drove it 480 kilometers. The rental cost for Wendy was $361.50. Charles rented the same car for 2 days and drove 300 kilometers. His rental cost was $173. What is the cost per day and the cost per kilometer to rent this vehicle? Now, you will need to start with let statements because we're going to be introducing some variables, so you have to let the reader know what these variables represent. Now, to get your let statements, all you have to do is look at the final question. Whatever the question is asking you to solve for, that's typically what your let statement should be. So, what is the cost per day and the cost per kilometer? So we will write those as our let statements. So let maybe D for day, let D represent cost per day, and let K for kilometers represent cost per kilometer. So let's set up our two equations. So we know we need two equations because we are talking about linear systems. So let's reread our scenario, and there should be two sentences here, one for each equation. Wendy rented a car for 6 days, drove it 480 kilometers, and here's the total cost. So for 6 days, each day costs D dollars. So let's say it costs $10 per day. You would do 6 days times 10 to get $60 in total. Well, let's just remove the cost that I made up randomly and put D there. If one day costs D dollars, 6 days will cost 6 times D, which we can write as 6D. And then for 480 kilometers, 1 kilometer costs K dollars. So 480 kilometers will be 480 times K. And in total, if I add the cost for all 6 days and the cost for all of the kilometers, it's going to be $361.50. And now let's look at our second equation, or our second sentence. Charles rented the same car, but he had it for 2 days, 300 kilometers, and the total was $173. So we can write an equation for that too. 2 days, so 2 times D for the cost of days, 300 kilometers, so 300K, and the total was 173. Okay, now we have two equations. That was the only new part or hard part. Now we just go ahead and solve with either substitution or elimination. Now in this scenario, we are really forced to do elimination because none of the coefficients in front of D or K are 1. So it wouldn't be easy to isolate and then do substitution. So I'm going to choose to eliminate the D variables because those numbers are smaller. So for 6 and 2, the lowest common multiple is 6. So my first equation is perfectly fine the way it is. I'm just going to bring it up here. So 6D plus 480K equals 361.50. But the second equation, we are going to have to multiply by 3 so that we can get 6D. So 2D times 3 is 6D. 300K times 3 is 900K. And then 173 times 3 is 519. Now we have to ask ourselves, should we add or subtract to eliminate the D's? And since they're both positive, subtraction will win. And we're going to subtract everything, so you can put that subtraction sign between every single variable and constant. So 6D minus 60 is 0. We don't write that. 480 subtract 900 is negative 420K. And then 361.5 subtract 519 is negative 157.5. And now at this point, we need to get rid of the coefficient of K. So we're going to divide both sides by negative 420. And that negative is super important because when I do negative divided by negative on the right side, it will turn positive, which is what we would expect for a cost. So when I do my division, I get 0.375. So that would be the cost per kilometer because we just found K. So I'll put $0.375 per 1 kilometer. So going back to those let statements will remind you what these variables represent. Okay, now that we have this, let's plug it into either equation. I'm going to go into the second one because the numbers seem smaller. So 2D plus 300 times the K value we just got equals 173. When we do the multiplication, so 300 times 0.375, you should get 112.5, which we can now bring over to the other side, and it becomes subtraction, so that I get 2D equals 60.5, and like always, our final step is to divide both sides by 2. So the actual solving is nothing new. It is just the initial setup and then deciding what your variables represent in the end. So I just got 30.25 for D. Going back to my let statements, D was the cost per day, so $30.25 per day. And because this is a word problem, we have to remember that we have to put a therefore statement. So therefore, it costs $0.375 per kilometer and $30.25 per day. And there we are. So this is a cost type of scenario. We're trying to find the cost of two things, and we're given two statements to get that. And the next one will be quite similar. So let's go ahead and try it. 3 footballs and 4 soccer balls cost $305. 2 footballs and 3 soccer balls cost $220. Determine the cost of 1 football and the cost of 1 soccer ball. So again, I go to the last sentence. Determine the cost of 1 football and the cost of 1 soccer ball. Those right there are my let statements. Let F represent cost of football and let S represent cost of soccer ball. Now we have 2 statements here. We have 3 footballs and 4 soccer balls cost $305, and we have 2 footballs and 3 soccer balls cost $220. Those 2 sentences will give you 2 separate equations to create that system. So why don't you pause the video here and try to just write the 2 equations. Don't go to solving yet so that you can check your work. So come back to the video, check your work, and then we'll go from there. So your first equation, 3 footballs, that would be 3F, plus 4 soccer balls, so 4S, gives us the total of 305. So if 1 football is F dollars, 3 would be 3 times F. If 1 soccer ball is S dollars, 4 soccer balls will be 4 times S. And if we add the cost of the footballs and the soccer balls, we get that 305. For the next one, 2 footballs, so similar idea, 2F, plus 3 soccer balls, 3S, equals 220. And then in this scenario, again, we would do elimination. We're kind of forced to do it just because none of the coefficients are 1, and we don't want to deal with that fraction. So looking at this, your choice what you want to eliminate. Let's just do the F's because the numbers are smaller, but S would have been fine as well. So that's what I'm going to do. So why don't you pause the video here, solve the system, write your therefore statement, and then come back to check your work to make sure you did it correctly, or if you made mistakes to see where you went wrong. All right, so if we have 3 and 2 as our coefficients, the common multiple will be 6, which means we have to multiply the first equation by 2 and the other one by 3. And I'm going to bring these up here. So we're going to have 3f times 2 is 6f, 4s times 2 is 8s, and 305 times 2 is 610. Now for the next one, 2f times 3 is 6f, 3s times 3 is 9s, and 220 times 3 is 660. So look at that, make sure all of your numbers were multiplied by the corresponding number. And now both the 6's in front of the f are positive, which means we're going to have to subtract everything. So 6f subtract 6f is 0, so that's gone. 8s subtract 9s is negative 1s. 610 subtract 660 is negative 50. A negative cost for a soccer ball would not make sense, so make sure you divide both sides by that negative 1 to get positive 50, and this would be the cost of the soccer ball. Now once you have this, hopefully you got that. If you didn't, check to see where you went wrong and make a note of it. I'm going to go into that second equation. So 2f plus 3 times 50 is 220. Simplify that multiplication. So that's 150. This part's very repetitive. Bring the 150 over, and it's with subtraction. And we get 70. And then we can divide both sides by 2 to get $35 for the football. Now, if you got both of those answers, that's great. All you have to do now is check your work to make sure you have your therefore statement. Therefore, one football costs $35 and one soccer ball costs $50. And that's it. So the elimination is nothing new. You still have to be careful, making sure that you multiply your equations by whatever you need to multiply them by to match the coefficients. Carefully add or subtract your lines to get your first variable, and then a little substitution at the end. So the only new part is writing your let statements, actually creating your own two equations, and then your therefore statement. All right, let's do one more together. So at a candy shop, cola gummies cost $8 per pound and fuzzy peaches cost $10 per pound. If you buy a 6-pound bag of candy for a total of $53, how many pounds of cola gummies and how many pounds of fuzzy peaches did you buy? So first of all, reading the question, how many pounds of cola gummies, how many pounds of fuzzy peaches did you buy? There's my let statement. We need to figure out the weight of each. So let C represent pounds of cola gummies. Let F represent pounds of fuzzy peaches. Okay, now our sentences are going to be slightly different because our first sentence says it's $8 per pound for the cola gummies, $10 per pound for the fuzzy peaches. So that doesn't really give me an equation just yet. Now here's the first statement I'm going to highlight. You buy a 6-pound bag. Now, I know that I have C pounds of cola gummies and F pounds of fuzzy peaches. If I combine those 2 pounds, those 2 variables, C and F, the total should be that 6 pounds. So your first equation is going to be C, cola gummies, plus fuzzy peaches gives you 6-pound total. So this is your first equation, just about the total weight. Now, your second equation is going to be about the cost. So we know that 1 pound of cola gummies is $8. Well, I have C pounds. So 8 times C will give me the cost of all the cola gummies that you're buying. And then fuzzy peaches are $10 per pound, and we have F pounds. So 10 times F will give me the total cost of the fuzzy peaches. And if I combine the cost of cola, the cost of the fuzzy peaches, my baggie will cost $53. So you have one equation here about weight, the top one, and the bottom one about your cost. Now, this is the one linear system in these 3-word problems where we can actually solve using substitution as well. because I can easily isolate for C or F, but completely your choice. We're just going to do elimination here though. So let's mix it up. Let's try to eliminate the other variable. So let's eliminate F in this scenario. So looking at 10 and that coefficient of 1, our common multiple will be 10, which means your first equation should get multiplied by 10 and the second one is fine the way it is. So 10 times C, 10 times F, and 6 times 10 is 60. And the other one I will just write out. All right, how about you continue from here? Decide if you should add or subtract, find your two variables, write your therefore statement, then come back to check your work. So subtraction is the winner here because 10 minus 10 is 0 for the F's. So 10 minus 8 is 2 C's. 10F minus 10F is gone. I'm not going to write that. 60 subtract 53 is 7. And then we can divide both sides by 2 to get 350. So that means we had 3.5 pounds of the cola gummies. And now I'm going to go into that top equation because it's a lot quicker. So instead of C, 3.5 plus F equals 6. Bring that 3.5 over. It becomes subtraction. And I get 2.5. So that's 2.5 pounds of the fuzzy peaches. Okay, and if I look at them, 3.5 pounds of cola, 2.5 pounds of fuzzy peaches, that is 6 pounds in total, so at least logically that makes sense. If I had gotten a negative number for one of these, that would not make sense at all because you can't have a negative weight. So therefore, you bought 3.5 pounds of cola gummies and 2.5 pounds of fuzzy peaches. And that's it for our elimination specific application questions. So all of these are cost related. There are patterns in them. So doing more practice, you will see the familiarity in these types of word problems, and elimination is just a tool or a method that you can use to solve them. And again, just a reminder, make sure you have those let statements, make sure you have that therefore statement at the end for your communication piece.